Next is characteristic equation. So what is the characteristic equation till now from our understanding? When we equate the denominator of transfer function to 0. That means transfer function, if you have a numerator function and denominator function d of s like this, then what will be the characteristic equation? This is going to be the denominator function equated to 0. Otherwise, if you are not equating it to 0, it will be simply called characteristic polynomial. Okay. If you are equating to 0, it will become an equation, which is called as characteristic equation. Now, in the state space variable, what is the transfer function we found out? This is equal to C into Si minus A inverse B plus D. Okay. Now, Si minus A inverse we can write as inverse of a matrix, we can write as adjoint of that matrix by determinant. That's how we have been finding out the transfer function, right? So, you can write C into adjoint of Si minus A divided by det of Si minus A, or you can also write as like this, right? This means the determinant of a matrix into B plus D. Now, you can also write this as C into adjoint of Si minus A into B plus determinant of Si minus A into D divided by Si minus A whole determinant. So that for the entire function you have a common denominator. What is that common denominator now? Si minus A, determinant of Si minus A. Then what will be the characteristic equation? If you equate this to 0, then it will become the characteristic equation. Okay.